Hello everyone, hope you're all well and surviving this pandemic. Hopefully it'll be over soon. But in the meantime, thank you also for looking at my presentation. Just before we get into the main presentation here, I just want to introduce myself. So I'm Rob Dobson. I head up our partners inside Device Authority. Been with Device Authority for over four and a bit years now. So seen a lot of change in IoT since that time. And what I really want to cover with you guys today is to discuss why is a root of trust and device brand identity a core component for trust and automation, independent of any human interaction. What is an automated PKI and standard driven proven trust fabric and why that's important for IoT. Why security automation layer becomes an important layer for different use cases and a wide set of use cases. And then the last thing here is we'll look at a couple of applied use cases and see how those work and what we've done as Device Authority to get those into reality. I always like to look at various statistics on IoT, and this actual figure here has been taken from a recent report Nokia did on the Threat Intelligence report in 2020. I think it's recently released a couple of months ago. And you can see here actually on these various colors on this pie chart, you've got Android, Windows, other IoT, and iPhone, etc. And you can see 2019, 16% of IoT devices were affected, and now there's 32%, so 100% growth in the last year, which is some massive amount of growth. And the reason why that's happening is because rogue and malicious actors are moving towards IoT devices, as they're seen as an easier entry point into companies' networks, and also an easier entry point to instigate things like DDoS attacks on other services and applications. I'd all encourage you to go and read this report, by the way. It's a really interesting read. Let's now talk about trust and why trust is important in IoT as it is in IT. Trusting IoT devices is a cornerstone, or the first fundamental point you have to have in your end-to-end security ecosystem and your end-to-end device security to ensure you can trust the data. If you can't trust the device, how do you trust the data coming from the device? And really what's driving businesses to adopt IoT is data and being able to do something with that data, whether it's understanding how to improve process yield on manufacturing lines, or how to gain valuable insights on some widget in the field. But it's that data which is really important. And of course, if you can't trust that data, then you've got your whole foundation of your business set on that, which is quite scary. So what do we mean by trust? Well, trust is all about how do we identify those devices? How can we trust those devices from the outset? How can we ensure they're authentic? Their identities are proven to us and to our networks, and then we can trust those identities and its authenticity. How can we be sure the integrity of those devices hasn't been tampered with? How do we know that the firmware on those devices hasn't been tampered with and it's the correct firmware and is running the right firmware? How do we know it's an authorized device that can access those network services? Be sure that it's an authorized device. Is it unique? Is it a clone device? How do we sure it's going to be authorized to connect to those network services, which are really important to us? This leads on to why is it really important for businesses? You think about safety in some environments like industrial. Talk about industrial boilers being connected. Also things like property damages, business reputation, liability, the list goes on. You have to have trust and establish trust right from the outset to be able to ensure that my people that are working around those devices or in those environments those devices are not going to be hurt in some way, for example. So really we need to have this unique, immutable, unclonable identity to enable authorization into your IoT network. That's really fundamental cornerstone of the whole, your whole IoT device deployment really is having that cornerstone. You need to protect against those and prevent against counterfeiting, cloning, etc. Again, you're not only protecting against safety and all those other things I talked about, but also protecting your revenue streams coming from those devices, and also preventing somebody trying to maliciously get in and use your devices to instruct some kind of DDoS attack or alternative. So really, the trust is really in those IoT devices is an established anchor point from which we can then establish a chain of trust all the way through to your IoT system into your backend infrastructure and then onwards. Without that chain of trust and that established trust in your IoT device, it becomes really, really difficult then to operate your IoT devices in a trusted way. So let's just spend the next couple of minutes talking about can we apply the same IoT identity and trust model to IoT? Now, both IT and IoT share some of the same fundamental concepts in identity and trust, but there are very big differences between them. You look at like the user typically centric access management. We call it, it's not a typical IAM type play, right? Where you want to connect your computer to your network or your corporate network. Typically, that's done through a username and password. Or can be passwordless these days, but typically it's a computer that's inside a corporate network and it's provisioned a certificate and it's then enabled to connect to to the company's network. The difference between IT and IoT is that devices are typically headless. They don't have a way to type in a username and password, being able to control the device locally, because typically those IoT devices might be deployed in the real world somewhere, or you can't really access them. And this is where that identity model changes a little bit. And this is where we see an IoT identity access management model coming into play, where you need to have a device-centric identity model rather than a human or user-centric identity model, where you don't really need to use username and passwords typed in to access a network. You need to have what we call a unified device and data trust model, which is focused around that device-centric identity model. And it needs to have a unique characteristic, so you can't use the same identity of a device across all your real set of devices. That would be really bad security posture and a really bad security hole in your solutions. And the final thing there is all about scale. So you think about how many users you might want to connect to your corporate network is a lot less than the scale of IoT. I mean, users connected to corporate networks can be reasonable size, but not the same scale as IoT. And you can see on this diagram here, we've got IoT devices still connected into your corporate networks or into your IoT applications. But the difference is, like I talked about, is that how do I manage those identity in a headless way, and how do I then manage the authorization of those devices to my connected services? And this is where we see and we call out actually IoT and IoT devices is the new perimeter to the Internet of Things. IoT devices is outside a typical corporate network, so identities is that new perimeter. And being able to control those identities, have a strong identity in those devices, is really, really important for building in trust in those devices and being able to authorize them to your networks in a well-rounded and strong way. Okay, let's spend just a little bit of time talk about why is PKI and automation important in the IoT trust model. We spent a couple of minutes there previously talking about what's the difference between IT and IoT identity model. But equally, IT and IoT can share the same fundamental concepts. In fact, they do. IoT devices need to be able to operate in the same digital world as IT, still connect to the same networks. So they still need to apply the same fundamental principles. And one of those, which has been well used over decades now, is what's called PKI. And PKI, for the benefit of those that don't know what that is public key infrastructure, and it's a framework set out for managing digital certificates, identity, public key encryption, and it includes things like policies, software, hardware. How do I manage certificates? How do I have a chain of trust certificates, and so forth? And it sets all that out as a framework, so you can apply that to your network infrastructure. And as I mentioned, you can apply that to IoT, and you should. PKI's combination of that encryption and authentication is the fundamental part which enables it to establish the trustworthiness online, and that's where that comes important for IoT. Where automation really comes in is back to how I was talking about what's the difference between an IoT device from identity model to an IoT identity centric model. And its scale is around headlessness for IoT devices. How do I touch every single device? And that's where you need that automation layer, right? How do I provision a digital certificate, PKI certificate, X509, for example, to my IoT device? And how do I manage the security lifecycle of that on an ongoing basis? It's no good to say, okay, I've got a million IoT devices, I'll just stick a static certificate into that device. A lot of use cases, in fact, all the use cases we see don't want to do that. And also, we've seen lots of models where companies are basically installing one generic certificate into all of their IoT devices. So it's a static, generic one which is not unique. If someone breaks into one of those devices, hey presto, they've got the keys to the kingdom. Not a good security posture. And so automation is critical for this. And being able to provision a certificate, renew the certificate, if it expires, what do you do if the certificate expires? They do. And how do I manage revocation to those certificates? It's really, really important. So we can operate in that standard PKI framework. But you need to have an automation there because of the nature of those IoT devices and that they're headless, and that you can't typically touch them to update certificates. And why would you want to do that for a million devices anyway? It quickly becomes unmanageable. And tying back to the network again, if I've got my IoT application in that network, how do I manage the certificates into my IoT application? This automation approach becomes really, really important when you get into your larger scale deployment. So I just want to spend a couple of minutes now talking about Keyscaler, which is Device Authority's product. And this is built for trust and automation in an IoT device journey. So really how you manage the security lifecycle of an IoT device. And also I'll touch on what we've been doing in this respect with Microsoft Sphere, and how we can overlay what we're doing in the lifecycle management with that Sphere platform. But first, some of you have probably seen this slide before. This represents what we call the IoT device journey. You've got steps 1, 2, 3, and 4, which is the traditional ones. Then we've got these additional steps 5 and 6. And I'll just quickly talk about those. So, step 1 in a device's journey is really, we say start from secure by design, right? So how do you build in trust? Having the right hardware is a fundamental element of that, and how do you build in that trust right from the factory or right from where it goes? So having secure boot, having that secure identity, that secure trust foundation is really, really important for all your IoT devices right from the outset. So once you've got that, your product might be then shipped to a distributor, reseller, and onto the owner, and then the owner has to install it and onboard your device or that device to the chosen IoT application. And that's what we call step 2, is that zero touch on provisioning. You don't want to have to handle every single device to onboard it. It just become a nightmare logistically. And then step 3 here is how do we manage the security lifecycle of that IoT device? Do we need to provision it with a credential certificate, or do we need to give it a key or a token so that the device can now authenticate to the IoT application platform? Equally, maybe you need to provide keys for managing secure updates, and that's something also you need to consider when you're building out your IoT product. And then the final one, number 4, is that enterprise integration. How do I connect to my enterprise's security functionality? For example, I might want to connect to a CA vendor to get my certificate signed, or I might want to use a HSM in the enterprise that I've already got as my real estate. And that's something that, Keyscale and the product we have here has connectors for, so you plug straight into that, along with all the IoT applications like Azure, AWS, Google, Cloud, and so forth. So that's the general flow. And once your device is up and running and it's in the wild, so to speak, then that's the sort of general flow of what's happening. But then there's step 5 and 6. So once your product maybe needs to be decommissioned, so what do you do? Just turn it off, forget about it, or do you want to revoke the certificate status? How do you do that? And then step 6 is if maybe you've got a lease model and you're leasing your product out to a bunch of customers, and you need to recommission the product. At which point you need to provision new credential and new identity to that device, and then enroll it back to your application again. So you can see the flows here. There's quite a lot going on, but that's the sort of the general standard flows of an IoT device journey. Then if you look at the Azure Sphere, now obviously Microsoft over the last 25 years or so have built the Sphere platform. They have these 7 principles of security, and they've built this Sphere IoT strategy now, and it's a very solid foundation, secure by design approach for building out that trust in your products. And what we're doing on top of that is layering that security lifecycle management. How do I provision the right identities and keys to communicate back to the IoT hub, and how do we manage those certificates and keys on an ongoing basis in this lifecycle? And we'll talk about that in a bit more on the next slide. So this is that Microsoft Sphere example I was just talking about. So we've got here in the middle, we've got Keyscaler, which is that identity access management platform for IoT, which can be hosted on-prem or in the cloud. We've then got your Azure Sphere device, and then we've got the Azure stack. We've got the IoT Hub, DPS, and the Azure Sphere security services. And I'll step you through this, what's happening here. So step 1 is that the user would import the Sphere Tenants Certificate Authority into the Keyscaler platform. Then that's the one-time configuration that has to happen. Then your devices, in this example, Azure Sphere device would, step 2, connect to the Azure Sphere security service to get what's called a bootstrap certificate. This bootstrap certificate is then provided back to the device. The device can then communicate to our Keyscaler instance here via mutual TLS, so standard libraries, nothing different in there. Most of these IoT devices will support mutual TLS, and it uses that bootstrap certificate and its identity to register and authenticate itself to the Keyscaler platform. At which point in Keyscaler, we've already set up a policy to say, hey, this device, which is a Sphere device, is going to connect through mutual TLS. We need to provide a certificate, a signed certificate, an EAP TLS certificate back to the Sphere device. At which point you can, if you want to, reach out to a certificate authority to get a device certificate signed, or use a private CA equally in that scenario. And then step 5 is then, okay, we've got a certificate signed, we're then going to provision that certificate back to the Azure Sphere device. And then that device can use that certificate, step 6, to join to a corporate network using EAP TLS as a standard way to authenticate in a corporate environment. And what this gives you really is an end-to-end lifecycle management for certificates connected to a strong root of trust in the Azure Sphere device. And these are fundamental problems which we're solving with the Keyscaler platform, so you can automate that security lifecycle management for your deployments, which is really, really, really powerful when you think about IoT. So let's talk about a couple of use cases. This use case here, which is the first one, is all about patient monitoring equipment. So you have a couple of gateways. One will sit very close to the patient. Another gateway will sit where the nurses might reside or might be quite remote. But the idea here is that you want to be able to secure end-to-end the flow of data from sensors that connect to the gateway into where the nurses might reside or the doctors reside and can receive that data. And actually in the middle here, you've got Azure IoT Hub. So actually all the data gets passed through the IoT Hub and onto the gateway. And we've got Keyscaler in the middle. And so what we're solving here is that whole automation problem is solving basically some governance problems around how do I ensure that Gateway 2 is receiving the right data from the correct gateway, and how do I encrypt end-to-end from the sensors going into the gateway to the Azure IoT Hub and onto the Gateway 2 to protect that data in transit and at rest. So what we're doing here in this environment is providing policy to encrypt data from the gateways into the IoT Hub and onto the Gateway 2 when it requests the data from the IoT Hub, and equally providing the automation for certificates as well into the gateway, because IoT Hub in this instance uses mutual TLS to authenticate the gateway to the Azure IoT Hub. And also the Keyscaler provisions an additional set of keys to give that extra level of provenance for the data, so that Gateway 2 can be sure that actually it's got the right data from the right gateway, and it's only allowed then to decrypt that data by proving its authenticity to the Keyscaler platform. So it's giving that end-to-end security lifecycle management, onboard registration, and key management. So this one here is all about PKM management for connected car. In fact, we've seen a significant growth in this area in automotive, to be honest. And what we've got here is we've got Keyscaler again in the middle. We've got vehicle, or inside the vehicle is what's called a telematics control unit. And then we've got the connected vehicle platform on the right hand side. And the whole flow here is all about, well, how do I, at the end of production, manage getting certificates onto these edge devices, those TCUs, and then into my chosen connected vehicle platform. And so end-to-end Keyscaler is being used to register the vehicle's TCU to the Keyscaler platform, authorize that device to be connected, provision a new certificate to the device, and also into the chosen connected vehicle platform. At the same time, signing the certificates through the customer's chosen CA vendor, and automate the whole process so the vehicle's internal TCU can then communicate to that connected vehicle platform, so that you've got secure end-to-end transfer data to that back-end system. And it's fair to say that, that's just one example of connected car. There's many other examples in there which you could, and which in fact we're talking to customers about in that environment. So I think this is my final slide, and really this is just to summarize what we offer as a device authority. We have this platform called Keyscaler, as you've seen throughout this slide deck, and we provide that end-to-end data security, the device identity model as a device-centric identity access management solution. We provide that code sign and secure updates mechanism if you want to go down the route doing that, which I really encourage you to do. Adopting a secure by design approach and utilizing something like Keyscaler is really, really a must to enable you to manage your security on an ongoing basis. And being able to plug it into the enterprise is something which we offer. So we have connected to a whole bunch of IoT applications, platforms like the Azure IoT Hub, the PC Thing, where it's AWS IoT Core, and so forth. Please come and talk to us if you want to discuss in more detail about what we can offer and what other use cases we actually work on. And finally, I will just leave you with this. Thank you for listening, and I will be in the breakout room, so please feel free to come and see me. We can talk in detail, and I can answer any questions and further questions that you may have. Also, I wanted to draw your notice to a couple of points here. We are on the Azure Marketplace. You can actually go on there and trial out our solution. If you can't grab this link, from the slide, then you just go on to your marketplace and type in device authority, and it will come up. Feel free to play around with that. If you've got any questions, just contact me. And just to put a point of note, we have a future event coming up on the 23rd and 24th of February 2021. We're doing this virtual IoT Security Summit, where we'll be having a whole range of IoT ecosystem partners and speakers who will be coming to talk about security. Enjoy the rest of your day, and I look forward to talking to you.